Okay, Wildcat, today we're going to turn on page 50, graphing polynomial functions. Okay, what I'm going to do is I'm going to slide this paper up. Okay, and then what I recommend doing is pausing the video, okay, and then updating the first page of notes. Okay, all right, at this point I assume you've paused the video, you've written down this first page, and are ready to move on to the next page. So let's go ahead and do that now. All right. Okay, graphing polynomial functions, general page 50. Graphing polynomial definitions. Turning point, a point on the graph of a function that corresponds to a local maximum or minimum where the graph changes from increasing to decreasing or vice versa. Okay. A local minimum. For a function f of a is a local minimum if there is an interval around a such that f of x is greater than f of a for every x value in an interval except a. Okay, a local maximum. For a function f of a is a local maximum if there is an interval around a such that f of x is less than f of a for every x value on the interval except a. Okay, now I know those definitions are somewhat difficult to understand, so I've drawn a picture to hopefully simplify local maximum, local minimum. Okay, so this is a local maximum, which is also a turning point, and this is the local minimum, which is also a turning point. Okay, all right, so if you would finish up that. All right, now let's take a look at example 1. All right, use a graph in calculator to graph the function, then use the graph to determine the number of turning points and the number of type, global or local, but not global, of any maximum or minimum value. Okay, so let's go and do that now. So I'm going to go to my Inspire. I'm going to go to Add Graph, and I'm going to type x parentheses x plus 3 parentheses x plus 2. Now it gives me an error, and the reason for that is you have to put a time symbol between x and a parentheses. So we do that, and now it graphs. I'm going to click on this and delete that. We don't need that. I'm going to go to Menu, View, Grid, Line Grid. Okay, so then you can kind of see your graph. Now what I'm going to do is press Control T and use a table to plot values. Now I'm not going to want to use -5, -30, but I can use -4, -8, -3, 0, -2, 0, -1, -2, 0, 0, 1, 12. Probably we could use it, but we don't have to. Okay. All right. So with that, we graph the points and then sketch the curve based on the Inspire. Now let's take a look at the questions. The graph has 2 turning points, and that's because it has one local minimum and one local maximum. Okay, so the function has one local maximum value and one local minimum value. All right, go ahead and finish up example 1. All right, let's take a look at example 2. Okay, use a graphing calculator to graph the function, then use the graph to determine the number of turning points and the number and type, global or local but not global, of any maximum or minimum value. Okay, so let's go to Inspire. I'm going to press on, new document. I always recommend using a new document every time. Go to add graph and let's type this in. So parentheses x plus 2, parentheses, oh, almost forgot, x plus 2 squared, parentheses x minus 2, parentheses, and then x minus 1. I'm going to click here, press delete, and I'm going to go to Menu, View, Grid, Line Grid. And I want to see the whole graph, so I can go to Menu, Window Zoom, zoom out, click once, there, press Escape, there's the graph. And then if I press Control T, I can use the table values. You're not going to want to use -3, or 20, but you can use -2, 0, -1, 0, 8, 1, 0, 2, 0, and you don't want to use 350. Okay? So we want to graph the points. Okay, and then sketch the curve using the Inspire. All right. Now you can see that it has a local min, a local max, a global min, and the global min is the lower minimum value. Okay, so it has 1, 2, 3 turning points. And we can say the function has one local maximum value, one local minimum value, and one global minimum value. All right, go and finish up example 2. All right, let's take a look at example 3. Okay, use a graphing calculator to graph the function, then use a graph to determine the number of turning points and the number and type, global or local, but not global, of any maximum or minimum value. Okay, so we're going to graph that, so go to on, new document, no, add graph. We're going to do negative x, make sure it times, parentheses, x minus 3 squared, press enter, and then we can click on this, press delete, we don't need that, menu, view, grid, line grid, control C, and we're going to graph these values. Negative 1, negative, or 16 is too far, 0, 0 is good, 1, negative 4, 2, negative 2, 3, 0, 4, negative 4, and then 5, negative 20 is too big. Okay, so we graph our points, and then use the Inspire to sketch the graph of the curve. Okay, now we can see here that we have one local min, one local max. We have 2 turning points, and we can say the function has one local maximum value and one local minimum value. All right, go ahead and finish up example 3. All right, example 4. All right, use a graphing calculator to graph the function, then use the graph to determine the number of turning points and the number and type, global or local, but not global, of any maximum or minimum values. Okay, so let's go ahead and graph example 4. So I'm going to go to on, new document, no, add graph, and then I'm going to do negative, parentheses, x minus 2, parentheses, x plus 1 cubed. All right, I'm going to click here, and then I'm going to go to menu, view, grid, line grid, and I'm going to go to menu, window zoom, zoom out, click once, there's our curve, press escape, and then I'm going to press control T, and I can see, I don't want to use that point, but I can use negative 2, negative 4, negative 1, 0, 0, 2, 1, 8, 2, 0, and that's too far. So we graph our points. Okay, now we can see that we only have one global max value, and this looks like it turns, but it doesn't. Remember, it has to go from increasing to decreasing. Well, this is increasing and went to decreasing, so that's one turn point, and the function has one global maximum value. Okay, all right. Good. Go ahead and finish up example 4, and have a wonderful Wildcat day.